Okay, friends of class 11 science, this is a video about normal reaction force. See, we break up the words normal. What do you mean by normal? Normal means perpendicular. This term has been used in class 10th also. What is normal? Normal means not samanya. It's not normal, sab kuch samanya hai. That's not normal. Normal mathematically means perpendicular direction. Okay, reaction. ये केमिस्ट्री वाला रिएक्शन नहीं है, ये फिजिक्स वाला रिएक्शन है. वी हैव लर्नड इन न्यूटन्स थर्ड लॉ अबाउट द एक्शन एंड रिएक्शन फोर्सेस. So what I'm talking about here now is the reaction force. So the force is normal reaction force. Okay, normal means it is acting in perpendicular directions, and reaction means it can never be action force. It is always born as a matter of reaction. Clear? Suppose if I'm pushing a wall, then the force applied by me on the wall is action force, and the force that the wall applies on my hand, that will be reaction force. Clear? Now I can apply force on the wall. That is my action. The force which I am applying becomes the action force. And the wall applies force on me. Wall मुझ पे कब force लगाएगी? पहले से वॉल मेरे पे फोर्स नहीं लगा सकती, पहले मैं वॉल पे फोर्स लगाऊंगा, तो वो वाला एक्शन फोर्स हो जाएगा. अच्छा, उसका जो रिवर्स इफेक्ट आएगा वो क्या है कि भाई वॉल भी मेरे पे फोर्स लगा रही है. ठीक है, दैट विल बी रिएक्शन. ओके, तो याद रखना, नॉर्मल रिएक्शन फोर्स कभी भी एज एन एक्शन नहीं आता है, वो हमेशा एज ए मैटर ऑफ रिएक्शन आता है. इट इज नॉट टेकिंग एनी इनिशिएटिव. आई थिंक यू गॉट दिस. ओके, सो अब ये काम कैसे करता है? व्हाट इज द डायरेक्शन? If there are two surfaces and the two surfaces are in contact, याद रखना, normal reaction force is always a contact force. If two bodies are not having any contact, there will be no normal reaction force between them. But if they are in contact, only then normal reaction force will be born. All right? Direction, perpendicular. It is always as a matter of reaction. Okay, let us calculate this force for a few simple cases, and you will learn more about this normal reaction force. Okay, see case number 1. Here I have a body of mass m. We can see this. This is the body of mass m, and this is resting on a surface, a flat surface. Clear? Now see, gravitational force is acting on all the bodies which are in the range of a planet, which are in range of Earth. Gravitational force is acting on all the bodies. And in which direction? The direction of gravitational force is always towards the center of Earth. So in fact, this mass is pulled down with a force of gravity. What is that force? That is m into g. All right. Now, in spite of that, the object is not going down. ठीक है, ये टेबल पे रखा हुआ कोई ऑब्जेक्ट भी हो सकता है. ठीक है, सपोज आपके घर में कोई भी एक टेबल है जिसपे कोई भी एक कप रखा हुआ है. सो इज द ग्रेविटेशनल फोर्स एक्टिंग ऑन दैट कप? यस, इट इज एक्टिंग. बट इफ in spite of gravitational force acting on that cup, is the cup moving down? No, the cup is not moving down. Now, why it is not moving down? आप बोलोगे सर टेबल है सर, नीचे कैसे जाएगा? That is in terms of a common man, not in terms of science. Okay, अभी साइंस की टर्म्स में सोचो तो यही होगा ना कि भाई there is some downward force acting on the body, but the body is not going down. It means there must be an upward force also acting on the body. Okay, what is that force? Because the object lies on the table. The table must have applied some force on the body in upward direction. Are you getting my point? I'm repeating. A body is placed on a flat surface like a cup placed on a table. Gravitational force is acting on the cup, but the cup is not going down. Okay, that means there must be some force which is countering the gravitational force. And that force comes only when the cup is in contact with the table. ठीक है, अभी एक कप टेबल के कांटेक्ट में नहीं है, ऐसे ही हवा में है, तो क्या होगा? ग्रेविटेशनल फोर्स उस पर काम करेगा, उसे नीचे खींच ले जाएगा ना, कप का मूवमेंट होगा, कप विल बी मूविंग डाउनवर्ड्स. बट व्हेन इट कम्स इनटू कांटेक्ट विद टेबल, तो उसका ग्रेविटेशनल फोर्स का असर उस पर खत्म हो जाता है. ठीक है ना? नीचे जाना कप बंद कर देता है. Why? ये बंद क्यों कर देता है? बिकॉज किसी चीज ने उस पर अपवर्ड डायरेक्शन में बराबर का फोर्स लगा दिया. ठीक है, किसने लगाया? टेबल के कांटेक्ट में आया तो टेबल ने लगाया. ओके, सो व्हाट इज दैट फोर्स? दैट फोर्स इज नॉर्मल रिएक्शन फोर्स. Okay, so what is the action force in this? Cup applies gravitational force, or cup applies some force on the table in downward direction. The table applies some force on the cup in the upward direction. That is what? That is normal reaction force. Okay, now you can see, because this mass is stationary, this mass becomes stationary. That means the upward force and downward force must be equal, right? So what is the downward force? Downward force is equals to mg. What is the upward force? Upward force is equals to n, normal reaction force. Okay, that means the upward force and downward force on the body are equal, and so the normal reaction force between that object and the flat surface is equal to mg. Okay, it's a very first example for normal reaction force, but it is very important also at the same time. Okay, you have to think about it, you have to grasp about it, so you can learn more and more about the normal reaction force. Okay, now let us learn the second example. Here again there is an object of mass m. You can see this is the object of mass m, and it is lying on a flat surface, but the flat surface is not horizontal, it is oblique. ठीक है, पहले में flat surface कैसा था? एकदम ऐसे सपाट था. ठीक है, हॉरिजॉन्टल था. नाउ इट इज नॉट हॉरिजॉन्टल, इट इज टर्न, इट इज टिल्टेड. क्लियर? सो हाउ डू वी कैलकुलेट द नॉर्मल रिएक्शन फोर्स बिटवीन दीज टू? हाउ डू वी डू दैट? सी, आई एम गोइंग टू ड्रॉ सम फोर्सेस. जस्ट सी. ओके, नाउ आई हैव this mass m resting on this flat surface. Now, see, the gravitational force that is acting on this mass, there is no question about it. Gravitational force is always in vertically downward direction. इसमें कोई exception नहीं होगा. Surface को टेढ़ा कर दो, कैसे भी कर दो. Okay, the direction of gravitational force will never change. It will be always taken as vertically downward direction. All right. Now, see, this angle is theta. So this angle will also be theta. एक बार फिर मैं इसको थोड़ा क्लियर करके बताता हूं. Okay, see, if this angle is theta, then this angle will also be theta. Right? Now you apply the logic and try yourself that why it is theta. Okay. Now if this is theta, then I resolve mg in two directions. This is the adjacent side, and this becomes mg cos theta. This is the perpendicular side, so this becomes mg sin theta. All right. Okay. Now see, now if the mass and the surface, they are in contact, तो normal reaction force mass पे लगेगा. ठीक है, कैसे लगेगा? It is always normal to the surface, perpendicular to the surface. Now you can see the mass is neither going down nor it is going up. That means the downward force and the upward force, the obliquely downward force and the obliquely upward force must be equal. Okay, what is the obliquely upward force? It is n. And what is the obliquely downward force? It is mg. These forces are equal and opposite. तो यहां से मुझे पता चल गया that what is the normal reaction force on this body? It is equal to mg cos theta. Got that? Okay, now we take one more example of normal reaction force. Okay, now see, this is the same example as previous one, but the only difference is the angle, a different angle is given. Okay, see, there is a mass m, and it is lying on a flat surface. Now, previously I had given you this angle. Now I am giving you this angle. Okay, direction of gravitational force never changes, never ever changes. It is in vertically downward direction. So this angle becomes angle theta. You can see how angles on the same side of transversal are equal. So if this is theta, then this is also theta. Resolve gravitational force. This will be mg cos theta and this will be mg sin theta. Okay, now coming to normal reaction force acting on mass m, it is always perpendicular or normal to the surface. So this is our normal reaction force, and there is one force which is equal and opposite to the normal reaction force. Can you see this? Okay, And what is that force? It is mg sine theta. So here how do we calculate normal reaction force? N is equals to mg sine theta. Got it now? Okay, in the next video we'll be taking about more complex examples of normal reaction force.